All right, so we're back here with the Advanced R Cohort 10. This week we're talking about subsetting, um, which I had to, you know, the planned presenter had to back out last minute, and so hopefully we're ready enough to talk about it. I went through the chapter, tried to update the slides, so hopefully it's good. I gave up. I ran out of time and just put a slide that is basically we don't have slides for these things. So we'll talk about those things just based on the book. But it's just a couple of things at the end. We'll see. I mean, it's not that long of a chapter, but there's a lot of information in here, and it's another one. I mean, like the last two, that where it's stuff that you might think that you have nailed, and then when you start digging in, you're like, oh, right, I didn't realize that, or that kind of thing. So, all right. So the learning objectives, the way I broke it down is basically we want to learn how to select multiple elements from a vector with, with the single bracket, um, and then select single elements from a vector with bracket, bracket, or $sign. We want to assign to subsets of vectors, and we want to use subsetting to expand data and do some other funky things. So, the bulk of this really is probably going to be about this selecting multiple elements section, but we'll see. We might end up running through it pretty quickly. There were a couple of things that I don't think I ever knew, or at least didn't remember in here. And the first one, so there are 6 ways to subset like the basic vectors. First one, positive integers, those get the things at that position. We're going to be working with this vector that he had in the book where it tells you where it is. So 1.1 is position 1, 2.2 is position 2, etc. And so if we say 4, 1, that is going to get us the 4th thing and the 1st thing. We can repeat. So 1, 1, 1 just gets us 1.1 over and over. And the one that I don't think I knew, I don't remember this, is that if you use a double in a real number, it truncates. And so, oops, and actually this was supposed to be just with this down here. So 1.0001 and 1.9999 get you the 1st thing both times. I didn't test if it ever, like if you go beyond the number of digits that are allowed or that are, rounded, if you do like a couple dozen 9s, if it'll ever see that as 2. I don't think it does though. So I don't think I knew that. Yeah, don't do that. Like that should be one of those that you can set a warning flag of if you're trying to select element 1.3, you probably have something wrong in your code. Like it's probably not intentional, but I think knowing it is probably useful for like any of these count as the 1st thing, basically. So I could see cases where that counts, and where truncate probably is the best way to go because you haven't made it to the 2nd thing yet. That one, but yeah, that was one of the interesting finds in this chapter. I don't know. I don't think I've ever intentionally done that, but who knows if it has happened and I didn't realize. All right, so next, negative integers remove specified elements. So we go back to our example, and I should have just expanded these out, but negative, you can put the negative in front of the vector, which is basically -1 times C1, 3, and that's going to get rid of the 1st and 3rd element. We could also say C -1, -3, and then also 2, 4 is the same as that. So we're saying get rid of those things. We can't mix negative and positive, so you can't, partly because it's ambiguous what that would mean. Like get rid of the 1st thing and give me the 3rd thing. Okay, but what do you mean get rid of the 1st thing? So do you mean the 3rd thing after you get rid of the 1st thing, or weird? So that's just an error. And it says only zeros may be mixed with negative subscripts. And I was like, wait, what? And so that led to a thing that he doesn't really talk about in the book, that when you have other integers, zeros are ignored. You can put all the zeros in there you want, and it just doesn't do anything with them. That was another one where I don't think I explicitly knew that. I don't remember it coming up ever. I can't imagine. Again, I don't think this would happen intentionally, but I could see it in some formula for figuring out what to select coming up. So mixed in with other numbers, zeros basically are just like ignored, that they get collapsed out of there. Again, that's one I did not know. Yeah, I could see it with a counter taking advantage of R's, like zero doesn't mean first, it means doesn't exist. Yeah. So, but, we'll see in a minute that zero on its own has a different meaning. So, it's a little bit weird. So, um, all right. So the third way of subsetting, so it was positive integers, negative integers. We had some other things mixed in there, but those were the sets. And then logical vectors specified the thing you specify. So at that element, like at that position. So true, true, false, true is saying get me the first one, the second one, don't give me the third, do give me the fourth. The nice thing about that is you can do Boolean, conditional logic. So X, where X is less than 3, you can just put that in as your subset, and that gets you any value that is less than 3. And then you can also like assign that condition to a variable, to a name, attach it to a name, and use that as your subsetting. This general idea, I use this often in code, where you're figuring out the logical subset that you want, and either you save that and pass it forward somewhere, or you just like use it immediately in the code. So definitely, a useful way to look at things. And I have some subset versions of these, or some special conditions. First one is that the shorter element out of your logical vector and your thing that you're trying to subset, they get recycled to the higher length, which can be confusing. So if you just say X false, that's going to get nothing. If you say X true, that's going to get everything. And then where it gets confusing is if you say X false true, and this has 4 elements, it's going to recycle that to false true to be the same length as your original vector. His advice, and it's not wrong, is if X or Y is 1, recycling, no problem. But if they're not, probably just spell it out. Again, there are cases like if you want to get every other thing, you can say false true or true false, and that'll get you every other row, for example. But for the most part, that can be a confusing way to do it. NAs, return NA for that position. So NA true gets NA 2.2, NA 4.4. And we'll see some like special versions of that. And I threw this in here because via a typo, I ended up with an extra position and went, oh, okay, yeah, if you have an extra true, that's going to be an NA. And so, false, true gets us the second, third, fourth thing, and then the fifth and sixth thing, which don't exist. So NA. Or if we just, that's also true selecting by integer. If you select the fifth thing in a vector of 4 things with single select, with this, or single bracket, it's just going to fill in NAs. And we'll see in a minute why I had to specify with single bracket. All right. Number 4, indexing with nothing returns the full original vector. So you can just include the index, but not put anything in there. That's different than, like indexing with 0, we're going to see in a second. Like literally nothing in there. Indexing with just 0 returns a 0 length version of the vector. With this, or which one? Well, let us know. I think it keeps everything. I think um it is largely as if you didn't do anything until you start assigning, I think. Um, and then 0 gives you something that has 0 length, but it is the same class as the input. So we have an integer that is called x, and we say x0, that's going to give us back this, or sorry, not integer, but it's a numeric vector, and it gives us back an empty numeric vector versus the built-in letters vector, which is a character vector. We say letters 0, it gives us a character vector of length 0. Again, there are cases where this can make sense in a programming context. Okay, so yeah, it keeps attributes. It keeps, like this one, returns the thing. All right. And then you can index with character vectors if it is named. So we had x, but which was our 1.1, 2.2, 3.3, 4.4. We can give it names of A, B, C, D. That was I just copy pasted, or not even copy pasted. I kept stuff from the old slides. I would have just done names, whatever. I see. They're creating Y at the same time that they name it. Yeah, that's fine. Okay. But yeah, so we can use these names, which is, this is the fourth name. So it's basically saying 4, 2, 1. It's equivalent to that. And it's going to get us the fourth thing, second thing, and the first thing. You can repeat just like you can repeat numbers. So AAA is 1.1, 1.1, 1.1. Let's see. And then names have to be exact for single, and we'll see why that's important, or why that distinction gets made when we get into the double bracket in a second. Kind of as you would expect, I would think in most programming contexts that you can't give it partial names, but we can in some other cases. So if we have a vector where the names are ABC and DEF, if you just select A and D, again, it's going to say, well, there is nothing at the A position and there's nothing at the D position. And actually there's no name there either. So it gives us back with the named, the empty name and empty value, since it's a named vector in this case. All right, and then we're going to go to lists. So that was all our base types, our atomic types. Sorry, not that this list isn't base, but it's not atomic. So we can have a list that is, a list of different vectors. And if you subset by name, it's just like if you subset a vector by name, it's going to give you back the thing at that position. So AB gives us A and B. Oh, and sorry, that was the thing that I'm pointing out here, is that it's always a list. So when it returns it, it's returning a list when we do the subset list. All right, and then it uses the same rules, so we can use, get the second and third thing, or we can use the logical vector to decide which things to select within the list. Oops. Matrices and arrays. Arrays are just matrices. Well, officially, matrices are a two-dimensional array. Used to be that they were completely different things, but yeah, a matrix is a two-dimensional array. So this works with 3 or 4 or whatever n-dimensional. That we can create this matrix and then select it by rows then columns. R is pretty much always rows and then columns. So we do 1 to 2, then 2 to 3. Gets us this, gets us this quadrant over here. Because it's row 1 and 2 and columns 2 and 3. They can also use character vectors or logical, etc. So if I name the columns in A, and then we select, rows true, true, false, and columns BA, it uses those rules, just like we could with a normal vector. Then the other weird thing to know about matrices and arrays is that they are vectors. So here, like the setup up here is just to create this like grid matrix that we can keep track of. Outer is going to combine 1 and 5 in all the combos, and via this function paste, and we're separating it with a comma. So we're pasting together 1 and 1, and then 1 and and then 2 and 1, 3 and 1, 4 and 1, 5 and 1 by column, making this whole combinatorial set. And if we just say we want the 4th thing and the 15th thing, it's going to give us, going by columns first, the 4th thing and the 15th thing. So 5, 10, 15th thing, as if there was no dimensionality to this. Similarly, if we use a logical comparison, it flattens it out. It ignores that they were columns or rows and columns. So effectively, you can think of it as first, it just collapses it into this vector that goes 1, 1 through 5, 1, and then 1, 2 through 5, 2, and then pulls the thing out of that. Sorry, and I did this with A because it's easier to do. A was our simpler matrix that just looks like this. And so, yeah, it just flattens that matrix down into a vector. And then data frames, the reason that they are this special thing, special data type, is they are like lists of vectors that have the same length, that act kind of matrix-like. And so with a single index, they act like a list where you're just getting the specified columns, because you're saying which parts of the list do I want? I want the first element, X, and the second element, Y. Or if I do it by name, it's going to do it by name, by getting the columns that you want by name. Versus if you subset with multiple indices, like if you use a comma in there, it acts more like a matrix. So it'll do rows, then columns, just like matrix did. I want rows 1 and 2, and columns X and Z, that gets that. If I say I want the rows where X is 2, and then just an empty value after the comma, that will get all the columns. So it gets the matching rows, all columns. Or if I do an empty value for the rows, it's going to get all the rows and then the matching columns, which ends up being equivalent to if we just hadn't used a comma at all. We just said C, X, comma, Z. A lot of that is easy to forget because when you're working with data frames, you tend to, at least I tend to think in this page and less in this, except when you're doing a $, which we'll talk about in a little bit. But I tend to think, df $X, yeah, that's a thing I think about. But the single bracket without a comma, I almost can't think of. I don't know. It feels like I don't do that very often. All right. Yeah. So tibbles, like lists, when you subset with single bracket on a tibble, one of the things that's special about a tibble is it will always return a tibble, versus by default, a data frame, if you say, oh, I just want column 1, it says, oh, well, column 1's just a vector. I'll just return a vector then. Unless you tell it, no, I want you to keep your structure. So that's the drop equals false. That's often good to do, is to prevent errors in code that you're writing. If you're like, oh crap, all of a sudden I don't have a data frame and I thought I was going to. And so drop equals false keeps the data frame shape or class, and tibbles just always do that. So my tibble, that's basically the same as the data frame. If I do the comma 1, it treats it basically as if I said drop equals false. All right. Any questions on the single bracket selection before we go on? Yeah. Well, and you also, after you drop, you lose the column name as well. So it can be uh, confusing, especially if the shape is kind of programmatically chosen or which columns to select, and then oh, oops, I only selected one column, and therefore it's a data frame or it's a vector now. If I select two columns, it remains a data frame. So that's something to watch out for, which is, again, why they made it not work that way in Tibble. All right. So single bracket gets you like tends to get you the shape or the class that you started with back. But double bracket, you're going to go down to just one thing within that object. So we're starting with just a list of a integer vector, a character, and then another integer vector. If we use a single select, we get the full first thing, which, sorry, as a list. That's the important thing. So, we got that back when we use single select versus when we use the double select, we get just the vector. It's the integer vector. And then, to line or finish our comparison to Hadley's famous hotel photo, if we do, we want the first thing, and then the first element within that thing will get us just that one that's at the beginning of the first element. And yeah, he had a hotel that had salt and pepper each inside of a salt and pepper shaker. And so X is the pepper inside of the shaker. X1 is just one of those things inside of the shaker. But if you do the double bracket, it's the whole packet. And then, it breaks down a little bit with the double because, I want to get down to, okay, you ripped open the packet, but then, yeah, I agree. So wouldn't X11 be a single speck of pepper? It is the first element inside of the pepper wrapper, which is everything. And so X111 would be a single speck, like grain of pepper, I think. It gets a little confusing there, but yeah. um, it was funny because I had a hotel room last year where they had the same thing, and I was like, oh wow, they have our teaching tools in this hotel room. Uh, but yes, all right. And yeah, something that's I don't know if it's interesting, but it's something to know is we could keep going bracket one forever on this because this is an integer vector of length one, and it'll return an integer vector of length one. It'll return an integer vector of length one. So you can like further subset once you get down to the base. That's just available if you have any reason to do so. Um, and then the next one that I don't know, it's easy to forget this one, I think, is $sign is bracket with exact equals false. And when this bites me, it really bites. It's like, wait, what? I was not expecting this. That you can have your list ABC equals 1, and if you say X ABC, you get 1. And if you say XA, it silently also just will give you 1 normally in R. Versus X bracket A, there is no such thing, so it's going to return null. It's going to say that doesn't exist. We can, with bracket set exact equals false. You rarely want that, probably. And there is an option, warn partial match $. I have this set to default or set to true by default in my settings because it's very surprising when this happens. If it happens without telling you. So that should be, it'll give us back the list 1 to 2, and then it'll give us back just the 1 to 2, the and contents of the packet, not the single grain. So yeah, that's a good example. Okay. Yeah. So I don't remember if I had time to like go into it, but I have had when you're assigning, sometimes programmatic or like semi-programmatically, whatever, we had some code that had something like $X gets some value or $X, and there wasn't an existing $X, but there was XABC, and so it's like, oh, XABC exists, I'll give it that. And like this totally wasn't, we were like, what the heck? Where's this bug coming from? Oh, because we use dollar, and dollar actually means exact equals false. So you have to watch out for that. All right. Yeah, so if you have missing indices or things that are kind of missing, like vectors and lists have slightly different outcomes. I just did this, I grouped them all together, that all of these things are going to give errors. So the vector version and the list version, if you subset, double bracket subset with null, that gives an error. If you do either one of them with a index outside of the range, again with double bracket, that's going to give an error. Single bracket, it'll just say, oh yeah, there's nothing there. And then for the integers, if you do by name, for a name that doesn't exist, it will error, or if you do NA, it will error. And you can kind of see why list wouldn't, because at that level, a list is like, it's like you're doing the bracket, or like a single bracket, kind of. And so it's saying, oh, I need the Cth thing, and there is no Cth thing, so it's just going to give us a null. But anyway, it's confusing. And so because that's confusing, and it might be hard to remember, okay, which one of those are going to give me errors, they have per pluck and per chuck. Pluck always, quote unquote, or asterisk, always returns null, except it still doesn't work with the null. So if you did pluck a comma null, it'll throw an error. But yeah, other than that, pluck always returns null, whether it's a list or a vector. And then chuck, I didn't put in the examples, but it's just going to always error when it can't find the value that it wants, or value that you ask for, rather than that it wants. All right. He does mention S4 has two other operators, at, which is like $, but it's like stricter, and then slot, which is equivalent to bracket bracket. We're going to see more of those in chapter 15 when we talk about S4. So if you don't have any idea what the heck this means, what is S4 and what is a slot, we'll talk about that more later. All right. And then we have, a section about subsetting and assignment, and I need to make sure that nothing important is coming in on my work computer. Okay, all good. And so first thing is that you can assign to a position using the single bracket. So if I've got this vector, has 5 elements, I can say the first and second elements I want to be 101 and 102, and that will just replace those pieces of that vector. Warning that recycling rules apply. And so if you say I want 1 through 3 to get 1 and 2, it's going to recycle 1, 2 and give you 1 again. Can be really confusing. So, generally try not to do that. Like, try to make sure you're assigning the same length. And again, it's fine when it's length 1, because if you say I want the first through third things to be 1, yeah, that makes sense. But if you say I want the first through third things to be 1, 2, it's not as clear what you meant to happen there. All right. Within a list, you can get rid of a component by assigning null to it. So we have this list, A equals 1, B equals 2. We assign X bracket bracket B gets null, then X just doesn't have B anymore. Versus if you actually wanted to put null in the list, you need to assign it as a list. So list null. And here, if we do that, then B is actually a list that has a null in it. And that's the only way you can kind of, keep your null around. All right. Let us see. Yeah, so for like that subsetting with nothing, we saw that it like retained the thing, that the type of object, or it gave you back, sorry, the whole object. And you can use that with assignment to assign every element of that object to whatever you're saying. So we have this data frame, and I say I want to assign to the entire data frame A. That's going to do it in like all of the slots within the data frame. And the reason that that is useful is if you think about, if you just assign df gets A, the data frame that you started with just doesn't exist anymore. You're assigning A to the name df. But the bracket tells it, no, I want the object that is df, I want to assign A inside of it everywhere. Again, I can't think of a lot of cases where I've used this on purpose, but I could see it coming up. I've definitely had things where I want a vector of true across the entire vector. And so I just could say, A bracket bracket or A single bracket gets true. To create things for like testing, or to create other things that are kind of the same shape of whatever you're putting in. I could see using that. All right, some actual applications other than just assignment. And this is where I didn't get all of these into slides, but we'll talk about what we have, and we can pull up the book if we need to. We can use a lookup vector and the recycling rules to translate values. So, we have this vector that is just, I changed it from sex to just something more generic of, we have, colors, and we can have like this missing color, but we can have these codes that expand out. And that's all this is about, is whatever you might have, you have this lookup gets expanded, or the lookup is like the details, and your vector gets expanded using the lookup. So within lookup, I want to find the things with these names. And, remembering that when you subset, you can repeat, and you'll get the thing that you repeated. And so if we say, BGXGGB, we get those values. If you need them just as kind of normal values, you can unname to get back just the full, text, blue, green, NA, green, green, blue. This can, I've used this kind of thing fairly often for, translating something to its value from some code or from a name or from whatever. So that can be useful. Likewise, you can translate, you can have like a full lookup actual table, not just a lookup vector that has all the information about the thing. And so we had that X, which was, again, BGX GGB. And we can just say match that X to that code value. Will give us indices. So 1, 2, 3, 2, 2, 1. And since we saw that indices still, work in subsetting of data frames, we can say I want info with those subset rows and all of the columns, and it'll give us our funky rows. I just realized that, yeah, because this is a data frame, we've got some row names that are a little confusing, but that's fine. It kind of actually calls out the fact that, 2 gets repeated, so it becomes 2.1 and 2.2. And then when 1 gets repeated, it's 1.1. But it works. It's no problem. R isn't like afraid of that. All right, some more applications. He talked about order a bit, that you can sort things with order. So a kind of a normal, more straightforward example of using order is, if you just have a vector that's out of order and you say order X, it'll tell you what the order is supposed to be for X, or what, how those would sort. And then you can use that to subset and give you the order. You can also do that with either the rows of a data frame. So I want to order this data frame by column B, put it in order 1, 2, 3. Or I could say I want to order the columns by the sorted names. So, and we can just, give that listing of the order of the columns. And it's, basically we're saying I want column 2 and then column 1, because the names of DF would come back as 2, 1. That's useful. All right, we can yes. Yeah.
I'm sorry. Yeah, the previous one, I'm too slow.
The
Like,
yeah.
yeah, these cases.
Yeah.
There's probably better way of doing it, but let's say you just have that, it works.
Yeah.
Because like the other thing
Yeah.
could be like a summary, like a mean or whatever's.
Like they had one that was, or his example was, grades, although it was just grade 1, 2, 3, and then it had a whole bunch of information that came along with that. So you have your vector of what actually came with it, and you expand it out into the table of all this stuff. So for site 1, this is all the info we know because it got this grade. But yeah, it kind of joining it back onto, expanding it out to match the input, or the subset.
Yeah, it's kind of a funny join.
Yeah. It's like a full join, basically. Yeah. Let's see. Oh, so kind of related to that, he had the example of expanding out counts. So if you have a data frame that is summarized and it tells you that, X2, Y9, there were 3 copies of that. Well, you can expand it back out. The rep is showing us how it's going to work. So we say 1 to n row df. I don't remember if we're going to see this eventually or if we've already seen it, but ideally you would say, sequence length n row df, because this could go 1 to 0 if there are no rows. But if you were just doing it in an example that we can see, it's fine to do 1 to n row df. And then we're going to rep that by this n column. So 1 gets repeated 3 times, and then 2 gets repeated 5 times, and then 3 gets repeated 1 time. And so 1, 1, 1, 2, 2, 2, 2, 2, 3. And then we can do that to say those are the rows I want. Is I want 1, 1, 1, 2, 2, 2, 2, 2, 3, and I want sorry, and I kept reading this wrong. This is our rows, and then comma, I want all the columns. And so again, base R is going to give us row names that show us that we're doing 1, 1 3 times, 2 5 times, and then 3 just once. Oops, and I had my, sorry, I have my other view over here, but the one that you're seeing, this is what I was trying to say, is this whole thing is the row selector, and then we say all of the columns. Okay, and then this is where I ran out of time to work on slides, but he also talked about, like using set diff, because again, you're just doing a logical vector of names, or of integers, or of true or false, or what, sorry, a character vector of names, or a logical vector or integer vector. All of those work for your index. And so you can do something like set diff of, I want all of the columns except these names, to get you a list of columns to select. You can also logically subset. So you can say, I want the rows that have this one value is greater than 5, or you can do an and in there and say it's, this one's greater than 5, but this other one is in this list or this vector of values, all that kind of thing. And then we have the next slide actually exists. Starts with is, I think it might be C under the hood, but it's equivalent to that, that it's doing these logical subsetting of names.
I should mention that because I think I always fail myself using set diff. I think set diff, unlike what you imagine on a set in mathematics sense, is like it is directional. So if you say diff A and B, you are gonna get different things on B and A, which,
Yes.
if I remember correctly.
Uh yes. So you do have to watch out for that. And
Yeah.
often, so like in his examples, he did a lot of this. This is what we're going to use to subset. This is what it gives you. And then we'll actually do the subset. I do find it useful to do this myself when I'm trying to like build up some code of, okay, is this going to give me what I think it's going to give me? Yes. Okay. It gives me this integer vector. Or, when you're doing the set diff, does an example that I know of give me what I think it's going to give me? Okay, then I will go ahead and programmatically do that. All right. So this last one, I didn't produce this slide, but I wanted to leave um, a thing in here to discuss this. That which is a function that turns a vector of a logical vector into just the integers where that logical vector is true. And so we can like use that in subsetting, but part of what he talked about here was, it depends on what you're doing. Like, logical vector also works. So sometimes you'll do this which of, oh, I only want rows 2 and 4, so I have to do this which to get to get 2 and 4 out of my logical vector. But you can also just use the logical vector. It's the same thing. I can't, like, again, this is where I ran out of time, so I don't remember what else he said here. Um, he had more to say there. I don't know. Does anyone have any thoughts on this section? Yeah, he says a common mistake is to use the which instead of just why. The which doesn't do anything.
Yeah, I never really like pay too much attention on it, but I will do because sometimes I do a set operation on huge table, and apparently like especially like if you have a sparse, I mean something that's gonna be converting sparse matrices, like if you have plenty, if you want few elements, apparently so that's the case, or you have very few true and many false. You should use the set representation, which is like basically
Right.
Boolean. Is
Okay, yeah. And
and
the other, oh, do you have more?
yeah, and well, I don't know. I guess it's because it's better implemented. I mean, you do one conversion maybe between like the logic. I mean, you convert basically like integer to logical, so you pay one conversion maybe. I don't know why it's faster, but yeah.
Well, I think it's the opposite, that when you do which, you're converting the giant logical down to just a smaller integer, and then you can, carry that forward without having to carry forward the giant um, vector. I think, that can be useful. The other one that I've done is like, I want the row after this condition. And so you can just do which y plus 1, and it'll give you
Yeah.
all of the values that are right after that. You have to be careful because, it can give you rows that don't exist and weird things like that. Or if it's NA, it's going to give you NA, or actually, which drops the NAs. And so you can
Yes.
silently confuse yourself if you're not careful.
Yeah, I will definitely have to read the Al page on which, because like I think one of the point of converting to an integers indexes is when you have NA also, because then you're gonna have
Yes.
like a numbers. I mean, you are gonna have an index from of the length of what you want to in. While if you
Yeah.
have like Boolean stuff, you maybe generate NA, and then as we see, it depends what you're gonna be returned.
Just that, he points out, yeah, which will drop the NAs, but it doesn't, it's not clear. Like, if you use which in order to drop NAs, probably at least leave a comment to future you of, this is why I'm doing this, because it's not obvious that that's what you're doing with the which. It's probably better to use is true around your vector in that case, because that's more clearly, I want the cases that are actually true.
Yep,
Yeah.
I agree.
But yeah, I have definitely, like, sometimes when I'm cleaning stuff for Tidy Tuesday, the data comes out just ugly and messy out of a web scrape or something. And so I'll say, well, I can't figure out the logic to get this row, but I can get the row above it. And then I just want the row after that. So I'll use a which plus one for some table. Like, it, when it's a table where every other row is formatting for the row after it or something like that. And it's just, it has information about what's on the next row. There are weird tables that do that. And so I'll end up saying, okay, I want any row that is after this value. And actually, I think less so in data frames, but in other objects, I'll look for which objects or which things say this. Then I want the the character vector that comes right after that word, that kind of thing. Yeah, so that's this chapter. There were a few things in there that like I said, that I forget whether I ever knew them or not. The subsetting by real numbers surprised me. Like, I didn't remember that at all. That you just truncate. I mean, I don't think I've ever tried to do this on purpose. We all do this all the time with just like 111. Those are real numbers, and that's probably part of why it truncates, is so that you don't get floating point issues on those. So if it technically is 1.0000001, it still counts as one. But yeah, it's that one is interesting, and then some of the finer points around like when you do exact matching or not, things like that are really important that you have to be careful about. All right. Well, I don't even remember. I looked at it and then forgot of what is next week. Oh, control flow. So here's where we get into like real programming. Once you have control flow, you can do all kinds of crazy things. So we have that, and I believe that it was Jacob is doing that one next week, and said that he is still available to do that next week. So we will talk about that next week. If you have any questions, ask them on the Slack.
No question, but like coming from R and using Python, the subsetting in Python is way different. I mean, not way, but very different. And one of these differences is the ability like to generate random row or random. To use the subsetting to multiply stuff. I mean, add rows or and I
Right.
think like, yeah, sometimes.
You know,
I didn't
the
realize.
ways
Yeah.
the ways R is weird about subsetting are like, one of the key things, like that's why R exists basically, is to let you work with data in ways that aren't necessarily normal in a lot of languages, but it's aimed at the way data, the way you would probably want to work. Well, any what you're doing, but the way that you want to work with data as data. But it definitely is weird. It does, does some things that are weird. Right down to that it does rows and then columns, and a lot of things do columns then rows. So that right off the jump makes things weird.
But thanks, John.
Okay. All right, thank you. And I will see everybody next week.
See you next week.
Thanks, everyone.
Thanks very
John.
much.
Bye.
And